Welcome one and all to the example on drawing the graphs of trig functions, specifically the graphs of sine and cosine. In the past several weeks, you have learned how to identify the different components, including amplitude, midline, and frequency/period. You've also learned how to identify and match the equations with the graphs, or vice versa. For this particular example, you will learn how to actually draw the graphs given the equation. And Delta Math is pretty nice. It is the best way to learn how to do this digitally and remotely as opposed to just doing this on paper if you were in class. But we'll make the most of it. Now, we do need to address a couple things though in order to have you guys tackle these problems on your own. So we are going to tackle this example together. So the first thing you need to do for these examples, and this is level 1 by the way, for drawing the trig functions, is you need to learn how to label the x and y axis. You have to do this before you are able to actually draw the graphs in order to submit your answer. So what we have to do is we need to make an appropriate scale, and once we do that, we can actually graph the one cycle. So let's identify all the different components of this equation. First thing we need to establish is, what's my amplitude? The amplitude is 3. So I'm going to say A equals 3. My frequency, my capital B, is my 7. That's the coefficient in front of x. As for the midline, nothing is being added or subtracted, so because of that, I know that it's going to be 0. The big thing we're missing is what exactly is our period, and this is the most important aspect of this problem. We need to know what the period is. If we don't know what the period is, we cannot do this problem, because the period is the length of one cycle, which is what we're drawing. As you should remember, the formula for period is 2 pi divided by whatever our frequency is. In this example, that is 7. So we do 2 pi divided by 7. The nice thing about this problem is that there's nothing else we can do beyond this. It is already in its simplified form. And now we can go ahead and label the x and y axes. So what I'm going to do is I am going to go back to the actual Delta Math. We've established that the amplitude was 3. So that means that I can find the max and mins of the graph itself. And to be safe, I'm just going to label that each line going up and down is going to be a difference of 1. As for my x-axis, this is where you just want to put directly onto this the period. So in this example, we said that the period was 2 pi over 7. So I'm literally going to write 2 pi fraction bar 7. So unfortunately, we can't get an actual fraction bar, but this is as best as we can do it. Once you've established what the period is for your x-axis and what the difference of the lines are for your y-axis, you click done, and then it'll set it up for you. And we're going to plot 5 points because, as you should know, one complete cycle of the graph has 5 key points. What we're going to do is I'm going to put this on the 5th line. Okay, 1. So this is technically my starting points are 1, 2, 3, 4. So technically 4th after the origin. The reason why we're going to do this is because now we're going to actually label our points. Now the next important thing is to establish that this is the sine function. So because it is sine, I'm going to erase that real quick because I just realized I don't want to confuse you guys with the midline. Sine is going to be very important to know because, as you should remember, the graph for sine is something like this, where it starts in the middle, then it goes high, then it goes mid, then low, then back to mid, which is not to be confused with cosine, which we'll do in a separate video, a different example. So what I'm going to do is I'm going to establish that because the midline is 0, I know that it's going to start in the middle, right here. Then the next point is it's going to go up. And we said that the amplitude is 3, so the highest point is 3. Then it goes back to the middle on the next x-axis. divider. So this is going to go back to the mid. Then I go down to -3. And then I finally end on the note that I clicked earlier, the 2 pi over 7. So notice that once I put my 5th point there, it automatically draws the line for me and I get this shape. Now, is it actually this narrow? For this example, yes. I could have spread it down further, and you'll see it in the correct answer once we submit our answer. So go ahead and submit it. And there you go. So they, in Delta Math, also do the same thing where they have you identify the amplitude, the frequency of the midline, use the frequency to get the period. I did not go as far as to identify the max and min. I figured that would be intuitive enough once you've had enough practice on the previous Delta Math assignments. And they also identify that the graph starts, sine graph starts at the midline. So notice that when they draw their graph, see how they spread theirs out so it looks a little bit nicer. But notice that they did the same thing I did. They started in the middle, okay? They went up 3, and they went 3 over. But notice that if you go 3 over here, they have to go 3 over to the next key point, which is in the middle, 3 over to get to the low point, and 3 over again to the last point. Now, I made it easier on myself to just go once every situation over, to go 1 over every time I find a key point. So mid, high, mid, low, mid. They do the same thing, but they just spread theirs out. And as long as it's an even distance between each critical point, then you're fine. So 3 over to get high, 3 over to mid, 3 over low, 3 over mid again. That's where the end. So that's one example of a sine graph. Check out the other video to see how to graph a cosine.